there. We're going to actually build an example paper airplane with my new articulations extension. Let me just show it playing. There's the paper airplane. It's flying, it's landing, and we're using Newton Viewer to accomplish this. Now, you might think this is overly complicated, but I actually wrote almost no code. I'm using my generative AI based code assistant, which runs in the background and says, well, what kind of physics should this paper airplane have? And let me go over it real fast. First, I'm going to start with a little bit of knowledge about I got the paper airplane from this Sketchfab application, which has all kinds of USD files, and I'm using Newton to display the physics of the paper airplane. Yes, I could have used Isaac Sim, and definitely that would have worked too. But I was trying to. I always like to kick the tires in any new simulator to try to work out what does it do and how does it work, etc. This is very focused on giving back feedback of the environment back to the model that's being created. So this is really focused on reinforcement learning, and being able to see what the effect of the environment is back on the model. Usually, if you're using Isaac Sim or Isaac Lab, you're usually getting the model's effect on the world, and the physics that happen around the world are not pushed back into the model itself. So you can see how important this is in something like this example, the panda robot moving the straw, or putting the straw, or getting the straw. I don't exactly know how to say that, but that is exactly what we're looking for. We're looking to get these kinds of the feedback back from the environment back into the RL model. And just to show that one, this might take a minute to load, but I can stall for a little bit while this is loading. Oh, it's cloning some things. This might actually take a long time. But the idea is that you can get back the physics back into the model. While this is loading, let me go ahead and explain what I've done in my own application. So I'm using USD view, and we'll start this over so you can see exactly what I did here. I grabbed a paper airplane. I'm going to name it paper airplane, and then I'm clicking on launch USD view. We might pause this while that other thing is compiling and loading, and once the screen loads, maybe we'll pause and show that one working, and then we'll come right back here as it starts to load. We then we have now the airplane. There it is. We want to go over to the object itself, the mesh file, and we're going to capture a few pictures about it. And why we're going to do that is we want to tell the generative model exactly what we have. We have a paper airplane. These are its dimensions. This is its mesh. These are its shapes. Those kinds of things. And you can see there's the airplane again. And then we go through this process. Lots of things in articulation here that we could do. Well, it came back, so let's just see it real quick. There it is. There, we putting the straw in the cup. And what you see before, yeah, it's done it once, and that's great. Let's see if I can run it. Oh, there, it's going to grab it again. No, it only did it one time, and then kind of failed. I haven't run that example before, which is why you never do anything in demo that you don't want to have fail in front of you. But let's see if I can run it again quickly, and if not, then there it is. So there it is. It's picking up the straw, and let's see. Oh, nice. Put the straw in. Very cool. All right, so it did its job. Awesome. And so many other demos you can look at on your own time. But here, what we're focusing on is creating this physics. And how do we do that? Well, the Newton Viewer supports certain material properties, rigid bodies, obviously soft bodies, deformable bodies, those kinds of things. Not so keen on liquids yet. We're going to get there. Cloth, the reason why I was super intrigued by this is I wanted to use cloth. But what I want to do is classify the materials of this object. So I'm going to say this is a paper airplane. And the reason why I'm telling it's anything, and I'm not letting the classification engine figure it out, is I want to actually tell it's a paper airplane. So it goes back and gets the lift drag coefficients. Look at that. It's calling this aerodynamic. I've created a custom aerodynamic solver. So I'm going to click on that, and yep. So it's calling this a deformable object, so you can actually crumple it up. That's a piece of paper. And I've clicked on apply to USD. So now it's added that to its knowledge, essentially, of what it is. The next step would be to generate Newton script. That takes a while, so I'm not going to do that for this one. But I've already done it, so I'm just going to show you the example. And here's the example. Go down to the end here and click on Run Simulator. And I gotta find my airplane because it's up in the sky somewhere. There it is. So there's my airplane. It's landing. It's we're seeing the all the fundamental forces: gravity, lift, drag, and all of those things happening on the airplane. Normal force for those of you who want to be complete. And you can see the airplane does land, and there it is. Beautiful airplane. There's a lot of other things you can do here. You can set up wind, so I can have added more wind to make it like not land as well, or change direction or whatever it is. The wind period and frequency, I could have changed all that in here. And yeah, I just think this is really cool. So I don't know exactly if I'm going to shift from PhysX engine inside of IsaacSim right now. I don't know if it's not that mature. As I said before, there's if you look at the release here, you'll see that it's not as mature as it needs to be, but we're getting there. Whoops, that's the wrong thing. But we're getting there. So here we go. Okay, and that's probably good enough for now. So if you got to this point, like and subscribe, and we'll talk to you soon.